Okay, today under energy changes, we'll be going through the energy profile diagram. So this is an energy profile diagram where you will have the axis over here. So the y-axis is labeled as energy and the x-axis is labeled as progress of reaction. So where you start your energy level will be from the reactants, then the energy level will go up, and then once it hits the peak, it will go down all the way to the products. So the energy profile diagram can be separated into three parts. The first is the initial energy of the reactants. This is the energy level of the reactants before the reaction begins. And then why is there a rise in energy and a decline in energy, which is shown over here? A rise in energy and a decline in energy. Energy is initially taken in from the surroundings to break the bonds of the reactants. When the energy is taken in, reaches or surpasses the activation energy, the reaction is able to take place. No reaction will occur if the energy taken in is less than the activation energy. Energy is then given off when bond formation occurs to form the products. And lastly is the final energy of the products. This is the energy level of the products formed at the end of the reaction, which is shown over here. Do take note that there are two types of energy profile diagrams, and they are for endothermic reactions and exothermic reactions. So if you can see here, the endothermic reaction, the reactant energy level is much lower than your product's energy level. Whereas for exothermic is the opposite. For reactant, the energy level is much higher than your product's energy level. For endothermic reactions, your delta H is positive. Why? Because if the final energy of the products is higher than the initial energy of the reactants, then enthalpy change is positive, and therefore it is endothermic. For exothermic, it will be the opposite, so your delta H is negative. If the final energy of the products is lower than the initial energy level of the reactants, then enthalpy change is negative, and thus exothermic. Do take note, for the arrows of activation energy and enthalpy change on an energy profile diagram, the base of these arrows should always begin at the reactants. What does this mean? If you can see from these diagrams over here, you can see that the base of arrow over here and over here, it always starts at the reactant side. Also, for your exothermic reaction, your base of your arrows always start at your reactant side, never at your product side. Reactants gain energy to reach the activation energy, and enthalpy change represents the change in energy between the reactants and products. And that is 2 minutes of chemistry. See you next time.